Guys, this is the first set of notes for Unit 3 in Academic Chemistry. So we're talking about Chapter 8, Section 1, Molecular Compounds. And we're going to talk about some stuff that isn't in the book. The book is just a very brief description. We're going to go into a little more depth than what you read in the reading assignment. So we're going to talk about covalent molecular compounds. Now, when you see the word molecular, it's talking about a molecule. And some people talk about any group of atoms as a molecule, but that's not true. If you're saying molecular or molecule, you have to have covalent bonds inside that compound. Now, a lot of times you're going to watch lessons on YouTube, or I've even had a college professor do that incorrectly. But in this class, we are going to be correct scientists. So this whole unit, we're going to be talking about molecules. But later, when we go into Unit 4, we're going to be talking about compounds that are not molecules because they do not have covalent bonds. So everything we're talking about today and in the next couple weeks are going to be specifically molecules, meaning they are compounds, so multiple atoms together with covalent bonds. Now we need to explain what the heck a covalent bond is then to understand fully. Okay, covalent bonds. These are when atoms are held together by sharing electrons, and it's generally between non-metals. So electrons are shared between two atoms, which causes them to stick together. So we have those valence electrons, those outer energy electrons, and atoms are hanging out, and the outside groups are like, oh, let's hang out together, and bloop, that's a molecule. So it occurs because both atoms are electronegative enough to pull the other electrons close to their own atom. So atom, atom, and they're both like, ooh, I'm electronegative, so I'm going to pull on the electrons of the other atom. So they're both pulling towards each other until, boom, they connect. And those outsides just link up. Those valence electrons on the outside are linked, and that is that shared pair. So one covalent bond is two electrons. Generally, it's one from each atom. It can be a little different, but for the simplest terms, it should generally be one from each atom, and they are shared. So if you see these atoms drawn here, notice we have the valence electrons on the outside. There are electrons further in, but for bonding, we don't really care about them. So this is your shared pair or your bonded pair. These are those two electrons that exist between two atoms. When you have two electrons between atoms, that is one covalent bond. And if you forget what covalent means, remember the prefix co is like sharing a space. Like when you cohabitate, you are sharing or cohabitating living. You're sharing a living space. And then valent, so covalent. Valent is valence electrons. So the outer energy electrons are valence electrons. So co means sharing, valent means valence electrons. So it means sharing two of those outer energy level electrons. So what compounds are considered covalent? Well, the difference in electronegativity between the two atoms is always less than 1.7. If the difference in electronegativity were greater than that, then one would be way stronger and just yank off the electron. The other one would be deficient in electrons. But if it's 1.7 or less, the difference in strength, that means they're both similarly strong and can pull equally on the electrons, so the electrons end up between the two, as opposed to one boop, pulling all the electrons away. Usually, but not always, there are some usually, all elements in a covalent molecule are nonmetal. And that's because if you look at the periodic table, on the top right, those are where the most electronegative elements are, right? Fluorine is your most electronegative element. So you need things that are strong to pull the electrons that share between them. Okay, so now we're going to talk about naming molecular compounds. You've gone through this in your activity. The rules are pretty easy. So we're going to go through them and then have some sample ones. First, molecules consisting of only one element are named with the element's name. So for example, oxygen. Oxygen is O2. There's also ozone that's O3, but that's a specific case. But oxygen, whenever you hear oxygen, is going to always be O2. Oxygen doesn't exist just as atoms by itself. So before, we were like, oh, oxygen, element, atoms. It's actually not. Oxygen doesn't exist as just atoms. It exists as molecular compounds of those atoms. Sulfur is another one. Sulfur doesn't really exist with just sulfur atoms. There's going to be 8 sulfurs bonded together because that's the most comfortable state for it. Phosphorus can have different forms. but P4, for example, is the type of phosphorus. You have 4 phosphorus atoms that are all bonded together to make one compound. And notice that the name of these compounds, they're compounds because we have a subscript, so there's more than one atom, is just the element's name. Now, there are 7 nonmetals that always have the form 2 next to it when they're elemental. So they are always diatomic. These are called diatomic elements or diatomic molecules. So they form whenever you have a pure sample of this element. And we just saw oxygen, for example. So oxygen is never just O by itself. If it's pure oxygen, it's O2. Now, this is only talking about when it's just that element. This is not talking about when it's bound to a different element. We're not talking H2O. Obviously, that just has one O, right? We're just when it's just that element. So these elements are more stable when they're bonded to another atom of the same element. So here they are. So nitrogen is always N2. If you have nitrogen gas, all of those atoms are bonded to another nitrogen. There are always 2 nitrogen atoms bonded together if it's just nitrogen. Oxygen, if it's just oxygen, it's O2. Fluorine, if it's just fluorine gas, no other element present, then it's F2. Chlorine, if it's just chlorine gas, no other element present, then chlorine always has a 2 after it. Bromine, whenever bromine is elemental, no other element, then it's Br2. Iodine and hydrogen follow the same formula. So one of my favorite ways to remember which elements have this funky little pattern of diatomic is Professor Brinkelhoff. So during my first year teaching, I couldn't figure out why, how am I going to get these kids to remember all these elements? Because I had been taught there's 7 elements and they kind of make this funny 7 on the periodic table, and then don't forget hydrogen. But then you have to remember boron's not included, carbon's not included, and then it's all the top and then down the halogens, but not astatine. So it's a lot to remember. And one of the fellow teachers I worked with said, oh, well, you don't tell him about Professor Brinkelhoff. He's the fan of the diatomic elements. He loves diatomic elements. So if you are trying to remember which element has the form when it is elemental, it is not with any other things in the compound, no other elements with it, think about Professor Brinkelhoff, and he loves diatomic elements. The rest of the rules for naming molecular compounds are going to be talking about binary molecular compounds, and the prefix bi means 2. So it's got 2 elements in it. Whenever you have 2 elements, use prefixes to denote how many of each element. So here are your prefixes. Mono is 1, like a monologue is 1 person talking. Di, like a dialogue, is 2 people talking. Tricycle, 3 wheels. Tetra, 4, it's like Tetris. Every piece in Tetris has 4 blocks in it. Did you know that? Penta, like the Pentagon, where the DoD focuses, has 5 sides to it. Hexa, a hexagon, has 6 sides to it. Hepta, I don't know anything that has 7 and hepta. If you know any, let me know. Octa is 8, like an octopus, has 8 legs. Nana, I don't know any examples, but it does sound a lot like 9. And deca, like a decade, has 10 years in it. So you're going to put prefixes in front of the element because to say how many of those atoms do you have. Pre means before, so put these before the element's name. But you never use the prefix mono for the first element. So only the first element. So like carbon monoxide, carbon is the first element and I don't have a prefix. So I can deduce, meaning I can just figure out that there's one of them, versus dicarbon tetroxide or whatever it happens to be, right? So in the first element, if it's 1 atom, don't put a prefix. If it's any more than 1, use a prefix. For the second element, always, 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 always use a prefix. All right, then you're going to change the ending. Well, let's name a few. I've got carbon dioxide, I've got diphosphorus tetrachloride, I've got sulfur monoxide, ide. Change the ending to ide, I-D-E, whatever the second element is. Don't do it for the first. For the second element, just change the ending to ide. Whatever sounds right is probably right. If the element starts with a vowel, this is the weird one. In general, you're going to cut the last vowel in the prefix, but there are some exceptions. So we don't have tetraoxide, we have tetroxide because, look, chemists are already nerdy enough. We don't need to add stutter to what they're already saying with tetraoxide, right? Just tetroxide. Beautiful. It doesn't always work, but sometimes, you're not going to have triiodide. You just have triiodide. Depends on the situation. Just think what sounds best, and that's probably right until you get used to it. All right, so what are the names of these compounds? So we're going to do two together, and then I'm going to freeze the computer. Well, you're going to freeze by pressing pause and figure out on your own. So the first one, CO, I've got carbon and I've got oxygen. I look to the subscripts to see how many. Since I don't have any subscripts, that means one. Whenever you're missing those subscripts, those numbers down below, then you can always assume one. So I'm not going to put monocarbon because you don't use mono on the first one. I'm just going to write carbon. But the second one has one, so I do put monoxide, cut the last vowel, monoxide, and notice oxygen went to oxide. So carbon monoxide. I've got one carbon because there's no prefix in the first one, and I have one oxygen. So that's how I read it. The next one, I do need a prefix because now I have two carbons. So this is dicarbon. Remember, the prefix came from over here, 2. And then I have 4 chlorines. So I need tetrachlorine, change the ending to "ide." Dicarbon tetrachloride. All right, I want you to freeze the computer and we're going to come back and I'll go through all the names. Great. So 1 carbon, 2 oxygens, carbon dioxide. 1 sulfur, 3 oxygens, sulfur trioxide. 2 nitrogens would be dinitrogen. Again, notice all these first ones don't change the ending or anything. Dinitrogen tetroxide. Notice we cut the A, tetroxide. This is silicon, but I only have 1 at the beginning. You don't put mono, so silicon hexafluoride. Phosphorus, no mono at the beginning, there's only 1. Pentachloride, phosphorus pentachloride. Great. Let's go on to, you have a name, come up with the formula. So the first one, I have silicon dioxide. Silicon doesn't have a prefix, so I know there's only 1, so I just put Si. Dioxide, O2, SiO2. Disulfur, so S2. Chlorine has hexa, so Cl6. You're going to freeze the computer and come back and do the rest. All right, iodine trichloride, ICl3. Carbon tetrabromide. Carbon doesn't have a prefix, so it's just C. Bromine has to have 4 to be tetra, CBr4. Dinitrogen trioxide. Di means 2. I have 2 nitrogens, N2. Trioxide means 3 oxygen, N2O3. Dinitrogen monoxide means 2 nitrogens, N2. Monoxide, just 1 oxygen, don't ever write the 1, so N2O. All right, have fun learning molecular compounds, and I'll be back with you at the next lesson.